Okay, good morning. I'm getting back to you on the problem, part C of question 14. So first thing I'm going to do is refer you back to the textbook. Because this is one of the things we need in order to do this proof. So this is a proof, and it's, students tend to shy away from proofs, and I know that they can be difficult. Sorry, I'm going to have to switch to my other browser. Okay. Okay, so the equation that we're looking for is on page 358, if I'm correct. Okay, so we're gonna, actually, sorry, it's a little further out than that. Okay, I think it's on this page, so I'm gonna go down. Okay, so we have these adding and subtracting rules for random variables. So x and y, we have the one that shows the difference. So we're going to assume for our problem that x is the first roll of the die, y is the second roll of the dice. So to justify why the expected value of the difference is 0, we'll be taking the mean of, or the expected value of rolling a die, and then subtracting it from the expected value of rolling a die. So we'll walk through that solution. Now, this is the part down here that you're confused about. So if I take I'll notice here that the variance of, this would essentially be finding the sum of two die, and the variance for finding the difference between two die is the same. We take the variance of the first die plus the variance of the second die, and that's probably where your confusion lies. So there's a couple things I'm going to do for you. I'm going to send you a video from Khan Academy that walks you through. And then I'm also going to share with you my own solution. So up here, x and y are random variables. Then I know that, like I just said, the difference in the mean is the expected value of that first die minus the expected value of the second die. But just like we saw, if I want to find the variance of the difference, it's the variance of the first die plus the variance of the second die. So essentially what I did, it just a FYI in a push for using the calculator, I put the rolls of a single die in the list, and then I ran the 1-bar stats on the calculator. I find the mean, which is the expected value, or mu sub x, equal to 3.5. So that would be the same for the second die. So x is going to be the first die, y is going to be the second die. So they have the same mean. And they would also have the same variance, which is 2.917. Okay? So here's the details of why the difference, the variance of the difference is the same as the sum of the variances. Okay, so why is this equal to this? So a few things to recall. Mu sub x is the expected value of x. And also, the definition of variance is the expected value of x minus mu sub x squared. Or, since I know this is true, I can then replace mu sub x with expected value. So this equation is going to come in handy later. So now back to the task at hand. So I'm jumping down here. So one little math trick I can play here is I could say sigma squared of x minus y is really the same as sigma squared of x plus negative y. So then if I expand that using the definition we learned in the chapter, that would be like saying sigma squared of x plus sigma squared of minus y. And this is where we're going to focus down here so that we can show you the proof. So now I'm going to expand this. So that's going to be, by definition, the expected value of negative y minus the expected value of negative y. So we're taking that whole difference and we're squaring it. I notice that I have a minus sign here and a minus sign here. So I'm going to factor out that minus sign and I'm going to square it. So then what am I left with is y plus the expected value of negative y, quantity squared. Now, we also learned earlier in the chapter that the expected value of negative y is equal to the negative of the expected value of y. So we're going to use that here. So watch what happens. We're going to take this equation. Negative 1 squared is 1. So that leaves us with this, y plus the expected value of y, quantity squared. Then I'm going to take this situation, or this statement, and I'm going to replace this with this. So expected value of negative y is negative of the expected value of y. Then I'm going to jog you back up. So if I go way back up here, recall that I said that the variance of x is equal to the expected value of x minus the expected value of x, quantity squared. Look what we have down here. We have the expected value of y minus the expected value of y squared. So that's got to be equal to sigma squared of x. So therefore, I can go back up to this equation right here. So I'm going to rewrite this line. So I'm going to jump down here. So this is equal to this, which is now, I can replace this with this. So that's why those two, that the variance is equal to the variance of the first plus the variance of the second, or twice the variance, since this and this are the same. Okay, so I hope that helps. I'm also going to be sending you a link to a Khan Academy video that walks you through in more detail in case you need that as well. Thanks.